Assalamualaikum warahmatullahi wabarakatuh. So today we will like to present to you our group mini project assignment about years of experience and salary.
Moving on into our group members. My name is Nadia Syakirah binti Muhammad Zain and my student ID is 2022931085.
Next, my name is SOFIATUN binti ABDUL RAZAK and my matrix number is 2022780519.
Lastly, my name is SYUHADAH binti NASEB and my student ID is 2022917659. So in our presentation, we will explain to you about our introduction, implementation, analysis and conclusion.
This is the real data that we obtained from the web. As you can see, we took 20 data points as comparing two variables which are X and Y. Our X is years of experience and our Y is salary in dollar. Introduction. The following data shows the relationship between the salary based on years of experience. Hence, in this assignment, we will use three mathematical models which are linear model, quadratic model, and cubic model. We are going to find out the best fit curves of the data in the previous slide.
Firstly, I will explain to you guys about the implementation of linear model. As we can see, linear model is more easier compared to quadratic model and cubic model. To proceed, we need to find the equation of the curve by using the least square method. The least square fit of a linear model is y equal to a plus bx. Next, we need to find our v by using the formula inverse of m transpose m times by m transpose y. Then, we can get the values of v's as shown in the slides. After we get our values of v, which is a and b, we substitute it in our least square fit of linear equation, which is y equal to a plus bx. So, we can get our best fit linear curve is as shown in the slides. Next, we need to find our error vector and our magnitude error vector, which the formula is y minus mv. As we can see in the slide, firstly, I substitute all the values in the formula first. As we can see in this slide, after I substitute all the values in the formula, I got the magnitude of error vector for linear is 12,665.9148. By using Maple, we can get our best fit curve for our linear model as shown in the slides. To obtain it, we use our least fit equation of our linear models and set x is between -10 and 10. Lastly, this is the graph of error vector against x values of linear model. As we can see, the graph is slightly in a gradient form.
Implementation for quadratic model. Find the equation of the curve by using the least squares method. The least squares fit of a quadratic is y equal to a plus bx plus cx squared. As you can see, the first matrix is our m. Next is our v and equal to our y. Then, we find our m transpose m to the power of inverse multiplied by m transpose y. After that, we have found our a, b, and c. Since the least square fit of quadratic is y equal to a plus bx plus cx squared, we can conclude that the best fit quadratic curve is y equal to 7994310184245 divided by 205.8589112 plus 588619144420 divided by 771970917 multiplied by x plus 1832822377175 divided by 1543941 1834 multiplied by x squared. B. Find the error vector and the magnitude of this error vector. For error vector, we have to take y minus mv. And then, this is what we got from y minus mv. And this is our magnitude of error vector, which is 11015.1439. In this slide, we have two differences of graph. Firstly, points of scattered data and best fit curve that have been calculated. As you can see, our x-axis is from 0 to 20 because we have 20 points, and our y-axis is from negative 6,000 to 10,000. Next, the graph of residuals, or the other name is error vector around the x-axis, which is y equal to 0. As you can see, our x-axis is from negative 10 to 10. And we can observe that our graph is in smile shape. Hence, these are two graphs that we obtained from application named Maple.
So, I will continue our presentation about the implementation for cubic model. Cubic model also same with linear and quadratic model, but the size for vector M is bigger than other. So, firstly, we need to find the equation of the curve by using least squares method. The least squares fit of cubic is y equal to a plus bx plus cx squared plus dx cubed. Next, we will use this formula to find the v, which are a, b, c, and d. The formula is inverse of m transpose times with m transpose times y. After we get our v, which are a, b, c, and d, we substitute the values into the least squares fit equation of a cubic, which is y equal to a plus bx plus cx squared plus dx cubed. So this is the best fit cubic equation curve. After that, we need to find the error vector and the magnitude of this error vector by using the formula, which is e equal to y minus mv. So after we substitute the values in the formula, we get the magnitude of this error vector is 9539.0052. This is the graph of error vector against the x values for cubic model. Next, this is the graph of best fit curve for cubic model. We use the least fit equation of cubic model to get the graph by set the x from negative 10 to 10, so we could see the right graph of cubic model.
Lastly, to conclude all, as we can see in the slide, the error magnitude for linear is 12,665.9148. The error magnitude for quadratic is 11,015.1439. And lastly, the error magnitude for cubic is 9,539.005. So, the best fit curve, which will give the best approximation, is cubic curve, which is it have the minimum errors in terms of its magnitude. With then, thank you.